Hi, we're almost at our first render. In this last lesson, we created the command pool and command buffer. In this lesson, we're going to write up the code that does the rendering command. I'll now split up this code here, which is responsible for initialization of Vulkan. And I will create a new separate set of functions, which are responsible for rendering. To render anything, we need to record commands in the command buffer. This means that we will need to make the buffer begin a set of commands. Then we will issue the commands, and finally we will have to end the command buffer and issue it to the GPU for execution. As you can see, we now have these three methods: begin commands, render triangle, and end commands. I'll now go to the CPP file to create bodies for all three functions. And I also have to put the graphics column. Now that we have them, we will start by creating our begin info object. We destruct after setting the S-type to command buffer begin info. We will call the vk begin command buffer, passing in the command buffer and begin info. Here we will check the begin state success, and this is not critical to initializing Vulkan, so we will throw a runtime error exception. We will now write up our first command. We want to issue a command to begin a render pass. This means that we want to make a certain frame to pass through the graphics pipeline. Remember, we bound the graphics pipeline to a subpass, which was part of the main render pass. To achieve this, we make a new struct called vk_render_pass_begin_info. We set the S-type to its appropriate value. Then we pass the render pass handle to the render pass field. Now we requested a few images from the swap chain. Then we wrapped those images with image views to use the Vulkan API. And finally, we made these image views into frames, also called frame buffers. Now, when we begin rendering, we need to choose one of the swap chain frame buffers. This frame will pass through the render pass for rendering. I would now add an index, since choosing which frame to send will be explored later. And I will also add it as a parameter here in the header file. Now we've selected the render pass and the frame buffer. We also have to set the rendering area in the command here. It has an offset of 0 by 0 and an extent that matches our swap chain extent. We would like to also include a step of clearing the frame when the render pass begins. We want to make the frame initially black, so I add a new vk clear value struct, and this struct has a few substructs where we only need to set the first one of the first one. This is why I write the three curly braces. And I set 0 for red, 0 for green, and 0 for blue. And finally, I set 1 for the transparency, which would mean fully opaque. The values go from 0 to 1. I need to pass this clear value to the render pass begin info. It can actually take a few clear values, so we set the count to 1. And then we pass the address of the value to the p-clear values. This essentially completes our render pass begin request. Now we have to call the command begin render pass. We pass on the command buffer, the address to the begin info, and also we pass the vk subpass contents inline setting. This setting can be set differently if you're issuing render commands from multiple buffers. But this is not part of this course. To render a triangle, we will need to bind the graphics pipeline. We do this by calling command bind pipeline. We pass in the command buffer, we bind the pipeline to the graphics bind point, and finally we pass in the pipeline. Now, if I go back in time a bit, when we created the graphics pipeline, I mentioned something about dynamic states. When you select some state as being dynamic, now when we record the commands, we will need to set those values. We essentially need to set this info here. So what I do now is go to the header file. I'll create two new functions, one for getting the viewport and one for getting the scissor. I go back in the CPP file just below the pipeline creation and I quickly add bodies for both of these new methods. I can then go to the pipeline code that implements them, cut this viewport creation and replace it with the code to the new function. Then paste the code in the new function's body. And also I will make the function to return the new object. Then I go back to the pipeline implementation and get the scissor code as well, replacing it in the process with the getScissor method code, so that I paste it in the getScissor method. Now back at the render triangle, we can now set those dynamic values. We get the viewport and the scissor objects by calling the corresponding functions. We can then call the vk command setViewport, passing in the command buffer, index to the first viewport which is 0, viewport count which is 1, and the others to an array of viewports or just a single one in our case. We have to do the same with the scissor. And sorry that I put this code in the render triangle. This is part of the things that we execute once at the beginning of the frame. Now that we have our render pass started, we also bound our subpass, talking about the pipeline here, and we set our dynamic states. We can issue a command for drawing. We request 3 vertices drawn, which are part of a single instance, starting from the vertex and first instance, which are both 0 indexed. Now that this is done, we can end our command buffer. This is done by issuing an end render pass command. This one takes only the command buffer. After ending the render pass, we also call an end to our command buffer as well. This one will have a result. If it wasn't a success, we will throw an exception. This concludes our rendering commands.